bit to Dr. Zaki, Dr. Pati and Dr. Turnat. I am Intan Fazrina and today I want to present about my final year project and the title is Mathematical Modeling for Predicting the Tensile Properties of Lalang Grass Fiber Reinforced Polypropylene. Firstly, I will start with the introduction of this project. Basically, composite is a material that is made from two or more materials. However, due to environmental concern, biodegradable materials have been used in the industrial and become high in demand. Therefore, natural fiber were used in the composite due to their ability to degrade and eco-friendly. The mechanical properties of the composite can be obtained by using mathematical modeling, where it enables fast and efficient data prediction. Now we move on to the problem statement. Due to both environmental concern and the lack of all derived products in the future, biocomposite have become the main subject in the activity research. However, the use of natural fiber in a polymer is still new and there are many unexplored options. Due to the limited time and cost, mathematical modeling can be used as an alternative to the experimental research. There are two objectives for this project. The first one is to predict the tensile properties of PP, lalang grass fiber, and to validate the predictive values with the previous experimental result. The scope of project include three categories. Next is the literature review is about the mathematical modeling. According to Bokhari et al., the correlation between the experimental and predictive value from the composite used showed that there is relatively good agreement between values obtained experimentally with the rule of mixture method. However, Ku et al. Stated that the Tensile method was found to be the most effective method for the prediction of the tensile modulus. This slide shows the process flow for this project. It started with the identification of materials to be used, then identification of calculation method was made. After that, the parameters were obtained from literature review. After the calculation is done, the validation of the result was made. As I mentioned before, there are three different methods used. Rules of mixture is one of it, and before proceeding with the calculation, we have to determine the suitable equation to be used. Therefore, the critical length of fiber is calculated using the formula. When the length of fiber is smaller than the critical length, then the shown equation was used to calculate the tensile strength. The second method is the modified rule of mixture. According to Angelo et al., the modified rules of mixture predicts better result for the tensile strength. This is because in real composite, it is not possible for it to have a perfect matrix fiber bonding. The fiber-fiber interaction will reduce the load-bearing capabilities. This method is called Tensile. According to the study for Angelo et al., Tensile equation was found to be the best method to predict tensile modulus. Shown is the formula for this method. These are all the parameters obtained from the literature review and the volume of fraction for each composition was calculated. Now we are moving on to the result and discussion. This table shows the tensile strength of the composite at different fiber loading for rules of mixture and modified rules of mixture. The next table is the result for the tensile modulus of the composite at different fiber loading for rules of mixture and Tensile. This is the graph to compare the tensile strength with previous experimental result. The tensile strength from the ROM method is significantly higher than the experimental by 36%. Tensile strength from the modified ROM has a lower value when compared to the experimental value by 13%. This is because the clustering parameter was added into the equation, where it takes into consideration of the available fiber stress transfer area. This graph is about the tensile strength of the composite at different fiber loading for ROM and modified ROM. Modified ROM method produced lower values than ROM method. Tensile strength for the ROM method increased with increasing fiber content. Tensile strength for the modified ROM slightly decreasing as fiber content increases. This is because the amount of fiber present in the composite influences the fiber-matrix interfacial bonding. This is the graph to compare the tensile modulus with the previous experimental result. The tensile modulus for both RM and Tensile method show higher values than the experimental value. However, the tensile modulus in Tensile method is closer to the experimental value compared to RM method. The presence of this parameter in the equation where it used to fit the equation with the experimental data makes the Tensile value closer to the experimental. This graph is about the tensile modulus of the composite at different fiber loading for RM and Tensile. As you can see, the tensile modulus for both RM and Tensile method increased with increasing fiber content. Tensile method produced lower tensile modulus compared to RM method. In conclusion, the objective was successfully achieved. Tensile strength and modulus of PP lalang grass fiber composite was successfully predicted and validated using proposed method. It was proven that modified RM is the best method to predict the tensile strength because the value for the modified RM is the closest to the experimental result. While helping side is the best method to predict the tensile modulus of the composite since the value is the closest to the experimental result. Before I end the presentation, there are two recommendations that I would like to give. The first one is data should have been taken from the same material used. Other mathematical modeling methods such as inverse rules of mixture, Nine-Shear-Lag, and Mendel's et al. Should have been used to predict the tensile properties of the composite. This will ensure better comparison can be done and the best mathematical modeling can be chosen from the project. Thank you.